This is Physics Lab 5, Following Slinky by Caitlin Schmidt. For the introduction, I will be predicting the motion of a falling Slinky and analyzing the effects of the Slinky surroundings. Tracker will be used to track the motion. GlowScript will be used to create a computational model and to predict and model the ideal motion of the Slinky. The goal is to determine if the bottom of the Slinky stays stationary in the model. The key principles used are Newton's second law, including F net equals the change in momentum divided by the change in time, the momentum update formula, the velocity update formula, and the position update formula, the drag force, and both the gravitational and the Slinky force, and both of those are listed below. So this is the tracker, which is the observed motion, and I included a picture of the tracker, and the initial mass was 0.218 kilograms. The initial height that the Slinky is dropped from is 1.75 meters, and then that is the initial position, and the initial velocity is all 0 meters per second. These are the initial conditions for the ideal motion in the computational model. These are all the same as before. Now, here is the iteration for the computational model, which is, again, the ideal motion. And this includes 2 while loops, including the key principles that were used and some code to show the motion. These are the results, and that has the observed versus predicted position of the bottom of the Slinky, and this is measured in time per second and position in meters. And it is pretty similar, which is good. And the possible errors could be observed motion experiences, fluctuations due to external forces that are not accounted by the model, and inaccurate tracking point placement on tracker, which is human error. So now for the final discussion. Why does the bottom of the Slinky remain stationary? So the forces in the y direction cancel out. Although the gravitational force acts downward, the Slinky acts as a spring and counteracts the force with a tension force with equal and opposite magnitude. And what if we put a large weight at the bottom? Would it remain stationary? This depends. As long as we have a Slinky that is either long enough or has a large enough spring constant, which means that tension would equal the gravitational, the weight will remain stationary until the top of the spring reaches it.